Hey guys, this is Miss Pierce here. Today we're going to be looking at some more transformations, mostly with stretching our functions both vertically and horizontally. So let's take a look. In order to stretch a function vertically, we're going to have an a value in front of our function, and it's going to be greater than 0. Okay. Let's take a look at this example. So we have a function c of x. There is a 3 that's being multiplied to our function here. So here's what it looks like on our graph. Let's take a look at a few values. So we've got f of x is the black function. So f of -9 is -3, but c of -9 is -9. And f of 2 is 0, and c of 2 is also 0. Okay, they hit at that same point. And lastly, f of -3 is -1, and c of -3 is 3. Oops, sorry, I think I meant +1. There we go. All right. So going back to this, f of -9, -3, c of -9, -9, f of 2, 0, c of 2, 0, and f of -3, 1, c of -3, 3. Do you guys see what I'm saying? With the y values, how they're being multiplied by 3, how they're being multiplied by 3, how they're being multiplied by 3. So what are we describing with the effects on the y values? The y values are being multiplied by 3, which is causing that vertical stretch. Okay, let's take a look at another example. Now we're going to see how we can compress a function vertically. Okay, we're still going to have that a value in front of our function, but this time that a value is going to be between 0 and 1. So something like 1/2 or 1/3 or I don't know, like 4/5, right? Like something like that where it's a value between 0 and 1. Okay, but it's not negative because that would flip it. So there's that distinction too. Okay, so actually that might not be a bad thing to write, that it's not negative. Okay, let's take a look at our function e of x, which is 1/2 times f of x. So taking a look at what's happening to our function. Okay, let's take a look at f of 7. So f of 7's 2, whereas e of 7 is 1. Okay, f of 2, again, is at 0. Same thing with e of 2, it's also at 0. And last but not least, f of -9 is -3, and e of -9 is -1.5. If you hear that jingling in the background, that's my cat Ruth playing with the loudest toys while I'm making a video, of course, because that's what she does. Okay. So writing this all down, f of 7 is 2, e of 7 is 1, f of 2 is 0, e of 2 is 0, and f of -9 is -3, e of -9 is -1.5, okay? See how our y values are being multiplied by a half, being multiplied by a half, being multiplied by a half, okay? So when we describe the effects on each y value of f of x, the y values are being multiplied by 1/2, and that's what's causing a vertical compression. Okay, pretty straightforward, right? Easy to remember because the number between 0 and 1 makes it compress. The number when it's greater than 1 makes it stretch. However, now when we get to horizontal stretches and compressions, it gets a little bit funky. So let's take a look. Okay, So to stretch a function horizontally, we're going to have a value. Now it's in front of our x value inside the parentheses, okay? That should be like ding, 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 dinging, because something about lies inside might come in here, okay? So it stretches, when our k value is between 0 and 1. Oh, okay, so now it's stretching for our x values when it's between 0 and 1. So let's take a look at an example, right? So I've got this function q of x is f of 1/3 times x. It's inside our parentheses, and we need to evaluate some of these values so we can see what's going on here. All right, so you'll notice f of -2 is 0, whereas q of -6, that corresponding point, is also at 0, okay? See how they're kind of like matching up? And f of 2 is 0, and the corresponding point on q is 6, 0. Okay, now let's take a look at f of 0 is at 9, and q of 0 is also at 9. Okay, so when I write these out, f of -2, 0, q of -6, 0, f of 2, 0, q of 6, 0, f of 0, 9, q of 0, also 9. So you'll notice that there's no changes in our y values. However, our x values are being multiplied by 3. Our x values are being multiplied by 3. Our x values are being multiplied by 3. Okay? So the x values are multiplied by 3, which is causing that horizontal stretch. Okay, and it's that same premise before when we had f of x minus 3, and it was moving to the right and it was lying. Okay, when we have that smaller number inside, it is going to stretch the function. All right. Now, in order to compress, I'm going to use purple here. To compress a function horizontally, we're still going to have that k value in front of our x, and k is going to be greater than 1. So let's take a look. D of x is f of 2 times x inside our parentheses. Looking at the function at some of our values, let's take a look at f of 10. Okay, this is the point 10, 3. If I look at the corresponding point on D, this is the point 5, 3. Okay, f of 2 is 0, and D of 1 is 0. All right, and last but not least, I want to look at f of -6 is 4, and D of -6 is 2. Sorry. D of -3 is 4. Don't know where my head was at there. Okay. So f of 10, 3. D of 5, 3. F of 2, 0. D of 1, 0. F of -6, 4. D of -3, 4. What's happening to our x values here? Look at that. They're multiplying by a half. They're multiplying by a half. They're multiplying by a half. So even when I have a 2 inside, it's multiplying my x values by 1/2, which is causing that compression. So when I describe the effects on the x values are multiplied by 1/2, which is causing the horizontal compression. Okay. That's pretty much it, guys. The only thing I wanted to go over was there is a transformations recap here. There's a couple typos, so if you would just fix those in the horizontal shift, when H is greater than 0, it moves left, and when H is less than 0, it moves right. Okay? The only other thing that I needed you guys to fix is in the horizontal stretch and compression. This should be the K value, not the A value, all right? But this is here and really useful for you guys if you want to get like a quick little recap as to how all the transformations work at a glance, all right? Hope you guys have a great day, and I'll see you soon. Bye.